On this problem set, what we're going to work on is compound formation. First with compound elements that we know the oxidation numbers for, and then the next set will be with compounds where we have to designate the oxidation number. So if we look at the first one, which is barium and fluoride. Barium is in group 2, so we know that it has a 2+ charge when it forms an ion. Fluoride is a halide, so we know that it has a -1 charge. Smallest number that both of them can go into to form a neutral compound will be 1 barium and 2 fluorides. Because there are no polyatomics, we don't have any parentheses, etc. Down here we have zinc, which is a transition metal, but it's one of the three that we said was a non-variable oxidation number, so we know that it is 2+. Whereas selenium is in the same family as oxygen, so it's going to be 2-. We know zinc's got to be positive because it's a metal. Selenium is going to be the non-metal, so it's going to be negative. So then the smallest number that both of them will go into is 2, so it'll be 1 zinc to 1 selenium. Rubidium is in group 1. It has the symbol Rb. It has a 1+ charge because we know it's group 1. Carbon, since it's going to be the negative, if we look at it, has to be 4-, so carbon 4-. So the smallest number that both of these will go into will be 4, so we will have to have 4 rubidiums and 1 carbon. So we get Rb4 carbon. Silver is one of the other three species that are transition metals that we said that was non-variable, so we know silver is 1+. Phosphorus is in the same family as nitrogen, so it will be 3-. So the smallest number both of these can go into is Ag3P, so 1 and 3. Now, as we go down to the transition metals, such as osmium and molybdenum and tungsten, they're variable. So here we have to know that osmium is going to be osmium 4+, and we know that bromine is going to be 1-. So we have Br-. So we're going to need 1 osmium and 4 bromines. Okay. Molybdenum and oxygen. Well, molybdenum is 4+ here, so we have molybdenum 4+. Oxygen we know is 2-, so we get a 2- there. The smallest number both of these can go into is the 4+, is 4. So that being the case, we have 1 molybdenum and we have 2 oxygens give us 4-. Because remember, all compounds have to be neutral. Now, in C, we have molybdenum 6+ and oxygen. Wait a minute, we did molybdenum 4+, but over here we're doing molybdenum 6+. Oxygen is not changing. Just remember that most of the transition metals can be variable. So in this particular case, with molybdenum 4+, we get MoO2. If it's 6+, we get MoO6. So when we name this would be molybdenum 4 oxide. This is molybdenum 6 oxide. Okay. Tungsten is the weirdo that I really like, also known as wolfram. So tungsten is going to be 5+, but arsenic is in the same family as nitrogen. So we're going to get As 3-. Well, when we look at this one, the smallest number that will go into both of these, or both of these will go into, is 15. So that means we're going to need 3 wolframs and 5 arsenics. Now, don't forget, I'm not making these positions up. I'm using the periodic table. Group 1, Group 2, carbon family, nitrogen, oxygen, the halides, noble gases, transition metals, etc. So I'm not making these up. I am just identifying where they go. And this is how you start with elemental compounds that only have one oxidation state to make compounds. So it doesn't matter what the subscripts are. They are strictly a function, it does matter, they are a function of the oxidation states that the species will be. Some are non-variable, some are variable. And remember, if they're variable, I have to tell you which one. And this is done one of two ways. This is the easiest way, where I just give you the oxidation number, or this is where the Roman numerals come into play. So it's like ferrous and ferric. If I were to tell you ferrous, then I know that that's iron 2+. If I tell you ferric, I know that's iron 3+. Now, osmium, molybdenum, and tungsten don't have the us naming. You're just responsible for iron, copper, tin, and lead.